Welcome back, focused learners. Today, we are unlocking a true high-stakes topic in the IGCSE Additional Mathematics 0606 syllabus. We're looking at a concept that often feels like pure magic when you finally get it, but really, it's all about casting the exact right structural framework. I like to call this the wizard approach to Cambridge exams, because once you know the spells, the structures, you can literally conjure marks out of thin air. Today, we are specifically targeting the transformation of relationships into straight-line form. Now, if you've ever stared at a past paper, let's say paper 12 or 22, and you're confronted with a wild, non-linear graph or a really complex data table, and you're just sitting there wondering how on earth you're supposed to extract an unknown constant from it, don't panic. This explainer is built exactly for you. We are going to deconstruct this topic using the very benchmarks Cambridge examiners use to grade your papers. Think about two types of students we always see. Let's call them Alex and Sam. Alex is the overloader. Alex memorizes every single raw mathematical fact, every logarithm rule, every single formula, but applies zero analysis. Alex writes half a page of chaotic algebra, but never actually answers the prompt. Then you have Sam. Sam is the rusher. Sam looks at the question, does the math in their head, writes down a final answer, and completely misses the command word requirements. Both of them are throwing away marks, and we are going to fix that today by turning you into the absolute master of this exam.
Okay, let's dive into this and look at our roadmap for today's session. We are breaking this complex mathematical beast down logically. We're starting with the 15% challenge to understand the stakes. Then, we are uncovering the core principles of how examiners think. After that, we outline the absolute goldmine that is the method mark strategy. Then, we'll walk through standardized solving, dive deep into the deconstruct, solve, evaluate blueprint, and finally, wrap up with some critical examiner warnings that you cannot afford to ignore.
Section 1. The 15% challenge. The high stakes. Look, when you're prepping for a massive comprehensive math exam like the 0606, it is incredibly easy to get lost in the weeds. You end up treating every single topic equally. You spend hours on a basic algebra concept that might be worth 2 marks and then gloss over a heavy hitter. But here's the secret. Cambridge doesn't weigh everything equally. Knowing exactly where the heavy hitters are hiding is your very first strategic advantage. It's the difference between walking into the exam room blind and walking in with an X-ray of the test.
15%. Let that sink in. Determining unknown constants from the gradient or intercept of a transformed graph accounts for roughly 15% of your total exam marks in additional mathematics. 15%. That is massive. That is the literal difference between a B and an A star. Mastering this one specific transformation technique is a grade-defining margin. It is a foundational pillar of the exam. If you're struggling to bump your grade up, this is exactly where you need to focus your energy. This isn't just another math problem. It's a massive chunk of your final outcome.
The core syllabus requirement from Cambridge is crystal clear. You must transform given relationships to and from straight-line form to determine unknown constants from the gradient or intercept. Let's unpack what that actually means in the real world of an exam. It means taking a messy, non-linear relationship, say an exponential curve like y equals a times b to the power of x, and using logarithms or algebraic manipulation to force it into our trusty familiar y equals mx plus c format. So you take the natural log of both sides, and suddenly you have ln y equals x ln b plus ln a. You've just created a straight line, and from there you use that straight line's gradient and y-intercept to find your missing variables, a and b. It sounds beautifully simple when you just read the syllabus, right? But the actual execution, the application under the pressure of a ticking clock, is where the real challenge lies. That's where our friend Sam rushes and makes a substitution error, or Alex writes out 10 lines of log rules without ever finding the gradient.
Moving on to Section 2, Core Principles. What examiners really want. Because let me tell you, it's one thing to know the math. It's another entirely to know how Cambridge examiners evaluate it to award that 15%. You have to get inside the head of the person holding the red pen. The assessment framework heavily, and I mean heavily, prioritizes analytical depth over superficial breadth. Examiners are not just checking if you have memorized a wide, shallow range of mathematical facts or formulas. They don't care if you've memorized the textbook. They are looking for logical, structured reasoning. This is where you need to decode the command words. Does the question say state, or does it say show that, or hence find? If a question says show that, and you just skip to the final answer like Sam does, you get 0. Literally 0 marks. They want to see that you deeply understand the mechanics of the transformation rather than blindly plugging numbers into a formula you barely grasp. Depth is where the marks live. You need a framework. A lot of top students use a variation of the Peel framework: point, evidence, explanation, link. Even in math, your point is identifying the relationship.
Your evidence is the data points from the table. Your explanation is the algebraic manipulation, and your link is tying that final constant back to the original equation.
So, why do students find multi-stage analysis and method marks so incredibly hard? It's a universal struggle. Before we answer that, and before we continue, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, back to the struggle. The answer lies in the cognitive domains that these multi-stage questions target. These transformation problems don't just test basic knowledge. They aggressively target application and analysis. You are required to synthesize multiple steps, carry errors forward conceptually, and hold a multi-stage plan in your head while simultaneously executing complex algebra. It's like juggling chainsaws while riding a unicycle. That's why it feels so difficult. It is specifically designed by Cambridge to test your absolute highest levels of mathematical thinking. It is supposed to be hard, but with the right framework, it becomes predictable.
Section 3. The method mark strategy. The process is the prize. If multi-stage analysis is the hurdle tripping everyone up, then understanding exactly how marks are awarded is your clear path over it. This is where we stop guessing and start playing the game by their rules.
So, the absolutely crucial point here is this. Marks are awarded for the process and clear working, not just the final answer. Let me repeat that because it is vital. You could mathematically arrive at the perfect, flawless final constant in your head, but if your working out on the page is a jumbled, invisible mess, you will lose out on almost all the vital method marks. If you look at a Cambridge mark scheme, you'll see M1, A1, B1. The M stands for method. Showing systematic, evidence-based reasoning is absolutely mandatory. Think of your working out as a map you are painstakingly drawing for the examiner. If they cannot follow your map step by step, they will not give you the treasure, even if you manage to teleport to the destination. Our student Sam loses 50% of his marks here because he thinks the examiner is a mind reader. They aren't. Show every step. Section 4. Standardized solving. The procedural framework. By utilizing a standardized sequence to approach absolutely any straight-line transformation problem, you completely remove the exam panic and replace it with pure, structured execution. You cast the spell, and the problem solves itself.
Let's walk through this exact standardized solving sequence. It's 5 steps. Step 1. Identify key elements. What variables are explicitly given, and what constants do you actually need to find? Decode the command word. Step 2. Apply relevant principles. This is the strategy phase. Do you need to take the natural log of both sides, or perhaps just divide everything by x squared? Step 3. Execute analysis with clear working. Write it down. This is where you secure those M1 method marks we just talked about. Apply the math equivalent of the Peel framework here. Step 4. Verify results. Does your calculated gradient actually make logical sense with the data provided? And finally, step 5. Present in appropriate format, capital Y, capital X. If Alex used this framework, his chaotic half-page of numbers would turn into a clean, logical progression. By systematically processing the problem through these 5 exact steps every single time, you guarantee that absolutely no method marks are left behind.
Now, executing that 5-step sequence relies heavily on critical data interpretation skills. Often, these exam questions don't just hand you a nice, neat equation. Oh no, they give you a table of raw, messy data. You must extract that data accurately. You have to interpret the complex, nonlinear relationship it represents, mathematically transform the data points to plot a straight line, maybe plotting ln y against x instead of y against x, and finally, draw evidence-based conclusions from your line of best fit to find your gradient and intercept. If your initial extraction is flawed, or you plot the wrong axes, your entire transformation will be off, and you'll be carrying errors through the whole page. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's move to Section 5, Deconstruct, Solve, Evaluate, the insider's blueprint. To truly conquer the higher-order questions, the ones that separate the top-tier A-star students from the rest of the pack, you need a more robust framework to fall back on during those intense moments. Welcome to the interactive workshop part of our session.
This blueprint requires a brilliant 3-pillar approach. First, deconstruct. Imagine a complex data table on the screen right now. Challenge number 1, you have 60 seconds. Scan the data. Don't just start blindly calculating. Identify the info and break the problem into logical steps based on what you see. Is the y value growing exponentially while x grows linearly? That's your first clue.
Second, solve. Work through your transformation systematically, writing out every single algebraic step. Challenge number 2, find the flaw. Imagine a paragraph of working out where a student goes from y equals ax to the power of n straight to log y equals n log x. What's the flaw? They forgot the constant a. They lost a mark right there. Third, evaluate. This is the step 90% of students skip. Check your final constants for reasonableness. If you're modeling bacterial growth and your calculated constant implies a shrinking population, you need to reevaluate your steps immediately. Make justified recommendations based on your solid mathematical evidence.
Occasionally, the exam throws a curveball and asks you to engage in comparative analysis. Maybe they want you to evaluate alternative approaches to finding straight-line forms. When this happens, we have challenge number 3, speed writing. You have 30 seconds to formulate your response. You must explicitly detail 4 elements to get full marks here. 1, identifying both similarities and differences between the methods. 2, using clear comparative connectives in your explanation, words like whereas, conversely, or in contrast. 3, supporting every single comparison with hard numerical evidence directly from your graphs or tables. You can't just say method A is better, you have to prove it. And 4, drawing conclusions about which method has greater relative importance or accuracy and why. It's all about showing complete, undeniable command of the topic from every possible angle.
We are now in Section 6, Examiner Warnings, Pitfalls to Avoid. Cambridge publishes principal examiner reports every single year. Most students never read them, but they are absolute gold mines of information. They literally tell you exactly what not to do. Let's look at the exact pitfalls you're going to avoid.
Based on those reports, here are the top 3 reasons students lose incredibly easy marks on the 0606 exam for this specific topic. Mistake number 1, forgetting to include the proper format. If you transform the equation but forget to write it clearly as capital Y equals M capital X plus C, the examiner assumes you don't fully grasp the concept. Mistake 2, skipping format and presentation checks entirely. I'm talking about messy graphs, unlabeled axes, plotting dots without a proper line of best fit, or sloppy, unreadable algebra. If they can't read it, they can't mark it. Mistake 3, giving answers that aren't specific to the context given. If the question specifically asks for the initial velocity based on your y-intercept, do not just write c equals 5. You must write initial velocity equals 5 meters per second. Context is everything. I strongly urge you to prioritize your presentation checks before you even think about moving to the next question.
Now, what's really interesting about this slide is a critical examiner alert that reveals candidates consistently confuse key terminology. You might mix up independent and dependent variables when discussing your transformed axes. You might swap your x and y by accident. The rule to fix this is beautifully simple. Always define your terms and state your transform variables clearly before using them in extended mathematical responses. Literally write down, let y equal log y and let x equal x. It takes 2 seconds, but it eliminates all confusion for both you, keeping your brain organized, and the examiner who is grading your paper. This ties directly into what I call the time management matrix. You cannot spend 20 minutes stressing over a 3-mark terminology question. Define it, apply it, and move on. Ultimately, the entire syllabus framework is looking for exactly this quote right here. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. Think about that. If you just memorize a formula, sure, you'll probably pass. But if you truly master the core principles, if you deeply, fundamentally understand why taking the logarithm of an exponential function yields a straight line on a graph, you can adapt to absolutely any trick, any weird dataset, or any unfamiliar context the exam decides to throw at you. You become bulletproof. That is the magic spell. That is the wizard strategy in action.
You now know the absolute stakes. You have the examiner's insider blueprint. You've learned the step-by-step standardized framework, and you know the exact specific pitfalls to avoid. So the question is, will you cast the right framework to master the method and claim your massive 15%? The ball is entirely in your court now. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep learning, keep structuring, and stay fiercely focused.